So, good afternoon, everyone. Welcome to the course on data structure and algorithm. Today is lecture 7, and where we shall address linear searching mechanism. In the last lecture, we completed a portion of introduction to the course, that is on algorithm analysis, along with uh, mm, one-dimensional array operations, insertion, deletion, and traversal. So now onwards, we shall be going into the actual data structure course. So let's start with some linear searching operation method and binary search method, and we will discuss about their complexity analysis. Okay, so today's topic will be on linear search. It's a very basic search. You have already understood and implemented that linear search in your previous course on C language programming. But still, we shall readdress linear search along with its complexity analysis. Okay, so today we shall be learning how to develop the algorithm for the method and do the complexity analysis. Okay, so I have shared my screen. I hope all of you can see my screen. Okay, so let's come to the logical part. So consider an array. The array is of size 10, and let's assign some values. Let's say here 11, 2, 9, 13, 57, 25, 17, 1, 90, and 3. So this is one array containing 10 elements, and we want to perform linear search mechanism on this one-dimensional array of 10 elements. Okay, so the logic is, suppose you have to search an element in this array, so you have to take that element from the user input. For example, I want to search an element, let's say 25. Okay, so this is my element of searching. So what I am doing, we are doing, the logic is starting with, um, so this is 25. This will be compared with this element, the simple if condition checking. The if the element 25 is equivalent to 11, yes or no. If it is yes, then if it is yes, then match found. Found the element. Found the element. Or if it is no, then what we shall do? We shall move towards next position, and again compare the element 25 and 2. If this condition is true or false. If it is true, then found. If it is not true, then we shall move forward to the next element, and we will compare the user given element 25 and 9. Okay, if it is again true, then found successfully. But if it is not found, if it is not matching, If the condition is false, then we shall move towards next position 13, and we will compare 25 and 13, right? And so again, condition is true, found. If false, then we will proceed further. In this case, we are further proceeding to the next element 57, and we are comparing 25 and 57, whether they are equal or not. In this case, it is not, the condition is not true. So again, we are moving towards the next element, which is 25. So now this condition becomes true. Now this condition becomes true. 25 is equal to 25. Yes, it is true. So match found. Okay. So we will stop there. We will stop there. Stop. Stop the process of linear searching and display the user that okay, your element has been found in the array at the position, some position. Let's say we start with, for layman understanding, index starts with 1, 2, 3, 4, 3, this is 4, this is 5, and this is 6. So your element 25 has been found successfully in the array at the position 6, at sixth position. Okay, so this is what we mean by uh, linear searching operation method mechanism. Okay, so if I want to search an element which is not 25, let's say some value, let's say 40. So what will happen? So you are further proceeding. This is your not 25 but 40, right? So you are keeping you keep going on comparing the user given element 40 with the array elements one after another. Okay, so 40 equivalent 25, no. So you are moving forward towards 17, comparing 40 and 17 whether they are true or not. No, they are not true. So you are further moving towards 1. 40 equal to 1, no. Moving forward. 40 equal to 90, no. Moving forward. 40 equal to 3, no. Moving forward. Then you are at the end of the array. Okay, so somehow if you can check further you check if you have reached, if you have reached end of array, end of array, if you have reached end of array, then you conclude your element 40 is not found in the array. Okay, so this is the logic of linear searching. I know that all of you have understood, and if anyone is having any problem, please raise your hand and ask me if you have any sort of doubt. I guess no.
Sir,
Yes,
sir,
yes, yes.
sir. So in linear search, basically we are traversing throughout the array to find the desired element, right?
Right. We are traversing along the 1D array and performing one by one comparison, 1:1 comparison.
Yes, sir. Yes.
Now let's go for in this course. That is, we will try to develop the algorithm. We will write algorithm for this very very easy basic method, which is linear searching. Okay. Algorithm development. So you read for n, Okay, read X. You want to compare, you want to find search X in the array. Okay, before that you may do that, though it's not, it's an optional thing. So for I equal to 1 to n, okay, to do ai is equal to read ai. Okay, what does that mean? Yeah, well, okay, writing here, uh, ai is this array is capital A. Okay. So this A is nothing but the ai. N. Okay. Here n is the size of array capital A. So we are denoting capital the array by capital A, and the and its array elements are denoted by ai. In subscript, it is I. Okay, so ai for all I equal to 1, 2, 3, dot 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 n. So as this is an algorithm, so I'm not actually starting the index with 0. You may start with 0; it's not a problem. So starting index with 0 is basically uh, mm, uh, uh, basically for the programmer, not for the layman. Okay. So we are assigning some values like this 11 to 9, 13, 57 through this two line. Okay. Then read x like 40. Then what we are doing, we are performing repeated comparisons. Comparison between the user given element x and each of the array element ai for all I equal to 1 to 3 dot 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 n. So for I equal to 1 to n, by default in steps, you may write this. In some algorithm book, you will see that in steps of 1, 2. So they are writing like this. They are writing like this. For I equal to 1 to n, in steps of plus 1, do. So even if you drop this, don't write. So by default, it will be assumed for the algorithm reader that the incrementation of the variable I is plus 1. Okay, incrementation size. So for, and if you want to say something, if your increment step size is not plus 1, rather something else, let's say, then you have to explicitly mention that. So for I equal to 1 to n, in steps of, let's say, plus 2, do like, which is not the by default size, which is plus 1. Okay, then you have to mention explicitly that. For I equal to 1 to n, what you have to do, you have to compare. So if my x is equal to, I'm not giving double equal to. So if x is equal to ai, then what you do, display x found at ith position, right? And then algorithm book, there you may not find ndif, but I'm explicitly writing ndif because of your uh, readability purpose. Okay, where if is starting, where it is stopping, etc. Like that. So now, if else, that's all. If I do not provide else, it will go to the if condition is false. Just try to understand on yourself that if this if condition is false, automatically it will go to the next iteration of the for loop. And in else part, what we are supposed to do? If I write the else part, if you want to write the else part, you want to go to the next iteration, right? Go to next iteration, and that you don't have to do explicitly using an else condition. Even if it is not there, if the if condition is false, automatically it will go to the next iteration of the for loop. So that's fine. And end for. So this is your done part. Now, what if x is not present anywhere in the array? So how to handle that situation? For example, 40 kind of element we are trying to search in this one dimensional array. Okay, will be failed output. I just told you during the logical part that somehow if uh, so if excuse me for a second. So now after that you have to check if you have reached end of the array. Okay, then then you display the message that x is not found. That's all. Okay, end if and stop. Okay, now how to do this? Whether you have reached the end of the array. Okay, so one way to do that, see, you may use the variable I. So if x is not found in the array, after the completion of the for loop, the last modified value of I will be equal to n plus 1. If x is found at some position, I will not become equal to n plus 1. It will be I less than n plus 1. Okay, so this thing we must understand. I hope some of you have already understood, but again, I am giving you here. What is the logic? Logic here for that part to establish this part. Logic is if x is found at any ith position. What is I? I means 1 less than equal to I less than equal to n at any intermediate position, first, last, or any intermediate position. Then what is the value of I? I is lying in the range 1 to n. So I is less than n plus 1. I can say that, right? I is less than equal to n means I less than n plus 1. But if x is not found at any ith position, then what I know that the I value will reach n plus 1,
Yes.
right? This is, I
Uh,
think, very clear. So that thing we will
yes.
use over here. If that condition is true, that I equal to n plus 1, thereby I can understand that x is not found. Hello? Okay, so this is the algorithm development part. Now let's move on to the the uh, the complexity analysis part. So uh, the first line for I equal to and this, for any kind of searching mechanism, linear searching or binary searching, whatever, this is fixed. There should be some data set which will be given to you, so that is not a problem. Okay, n is your problem instance, that is definitely, but this should be anywhere, whatever searching algorithm is there. Okay, you are applying, these two lines will be there. So this is not creating any difference between the algorithms. So this is like fixed instance. But yes, the value of n itself is a variable. The size of the array is a variable on which the performance of the algorithm depends. Also read x, this is also fixed, this is also same, it should be present in all the algorithms. So again, it is not creating any difference. So the main thing, I hope you can relate line by line. Okay, so this is that line for I equal to 1 to n. So how many times this for loop is getting executed, including successful execution and unsuccessful execution? Tell me, anyone. How
Sir,
many
n
times?
times.
Yes,
N times.
Answers.
yes.
N
Please
minus
repeat.
1 plus 1 times. Sir, n times.
How many times the for loop can be successfully executed? Maximum.
Sir, successful execution n minus 1 times.
Why? This is starting with I equal to 1. It will end with I equal to n. So 1 to n, how many
In
times?
times. So n times.
N times.
So for loop will be executed successfully maximum n
For
number
n
of
times.
times.
Yes.
And the
Yes.
last execution, when I will become equal to n plus 1, then that for loop will not be executed. It's a not be executed means its execution will be failed. So that's the only unsuccessful execution of the for loop. So including an unsuccessful execution, total number of times the for loop will be executed is n plus 1. And in each of these n plus,
N
and
plus
only,
1 including the unsuccessful.
yes, louder.
N plus 1 including the unsuccessful execution.
Yes, n plus 1 including the single unsuccessful execution of the for
Uh-huh.
loop.
Yes, yes.
Now, all these lines which are in the body of the for loop will be executed only if, only for the successful executions of the for loop, right? And how many times the for loop can be successfully executed? That is n times.
N times.
So maximum for those n number of times this body of the for loop will be executed. This if condition will be executed maximum n times. Display will be executed for maximum n times. Stop is not required. End if is not required. So these two lines we have to now think about how many times this if condition will be executed. Now concentrate on a single value of 1. Let's say I equal to 5. So when I is equal to 5, tell me how many times this if condition will be checked or executed.
Sir, n times.
Huh?
N times.
So 5 times. 5 times.
For a
So
single
five
value
times.
of I equal to 5, how many times that if condition line will be executed?
So 5
So
times.
that will be n times.
For a single value of I equal to 5, consider only single value of I equal to 5.
So one time.
Huh?
So
One
One
time.
time.
One time. For a single value of I, if condition is a single line, it's not getting repeated for a single value of I. It will be simply executed only once. Similarly, If this condition is false, true, then only display message will be executed. So we are not interested for the time being on finding number of times this display message will be executed. It will be executed, okay, even if you think about it, it will be simply 1. Why 1? Can you tell me why 1? Display message for the entire algorithm.
If the number is found only that time, only the display function will work.
Yes, and then we are facing that stop. So display message, if X is found at any position, display message will be executed only once throughout this overall algorithm. That is for sure. Maximum 1. It may be 0 if X is not found in the array. Now, if X is whatever we are doing, we are calculating, finding the maximum number of iterations. That means later you will understand, you will see, come to know that while doing complexity analysis of algorithm, there are 3 cases. One is best case complexity analysis, average case complexity analysis, and worst case complexity analysis. And whatever we are doing so far till date, that is the worst case complexity analysis. And in worst case complexity analysis, the number of iterations computed are of maximum value. Okay, so maximum number of iterations of display, maximum number of iterations of if condition, that lead towards the worst case complexity analysis. Okay, but best case, average case, we will do more elaborately in the next course, design analysis of algorithm. This is not part of this course. Okay, now if X equal to AI, this condition will be executed only once for a single value of I, for each value of I. Okay, so that is total number of executions of this if condition will be how much? 1 plus dot 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 for every values of I,
N.
right? Okay, dot dot dot. So that part we can write in very convenient way using the summation operator. Summation operator, yes. 1 for each value of I equal to 1 to n, and that is equal to n ultimately. Okay, so next, coming to stop, it's not required. Now this if condition will be only executed only once, and accordingly display will be executed either 0 time or 1 time. Okay, maximum 1 time in worst case scenario. Now calculating the total number of executions. So time complexity, more specifically, it is time complexity of linear search which is equal to total number of executions of all statements, and that is equal to n plus 1 plus 1 plus 1 plus 1, n plus 1 plus n. This is n. Second line, third is 1. Okay, next is 1, next is 1. So ultimately it is 2n plus 4. Okay, and let's give some notation to the time complexity function like Tn. Okay, this is your Tn. Tn equal to 2n plus 4. And what is our polynomial theorem on the time complexity function Fn? that if you have a time complexity function fn which can be expressed as a polynomial function of degree n. Okay, I mean a1, sorry, a0 plus a1 n plus a2 n square plus a3 n cube dot 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 plus an n to the power of m. The polynomial is of degree m. Then you may infer as per the theorem that that time complexity function fn will be the big O notation of n to the power of m. And here by polynomial theorem, the polynomial is a linear polynomial and which is of degree 1. So thereby we can conclude we can sorry we can conclude that Pn is in big O notation of small n. Okay, so linear complexity and its growth of, and if you just plot a graph, it will be very simple, just a straight line. Just a straight line like this. Okay, so I hope all of you have understood well. It's 127 and just as the algorithm is very simple, I can show you the code implementation also. It will not take much time, 5 minutes. Just seeing the algorithm, we have to do this. So let's say hash include okay, so for I equal to 1, right? For int I equal to, but as I am a programmer, I will start with 0. That thing I have to adjust with the algorithm. Okay, so both things will not be exactly same. Little bit adjust we have to do. So less than n, this ensures 0 to n minus 1 total n number of times. So I plus plus printf that is not created. If I do dynamically, okay, we can do that. In star p okay, and then star n, and here you take n, you take the size of the array from the user. That's fine. Okay, so I'm using a pointer. So here it will be just p. Okay, then you do one thing, make another pointer q for traversal. Let's 3 tr. Use that tr here. Okay, and then here you do tr plus plus. That's all. So reading is done. Then what we are doing, and for okay regex. So printf -- enter element you want to search, percentile D, ampersand X, here the linear searching code, that is for int I equal to 0, I less than n, I plus plus. Okay, here I'm doing if condition. If see I'm blindly seeing the algo and doing that, implementing that. It's equivalent to okay. So before here, I have to readdress the connection. Tr is equal to p. So here start here, start here. If that is true, then printf percentile d, that is x, is found at uh, at percentile dth position. Okay. First I have to display the x, then I plus 1. That's all. And step break or return 0. And if the if condition is not true, then it will keep going on comparing throughout the next for iterations. Here I will just want to check the if condition. If I is equivalent to n plus 1, then printf slash n percentile d is not found. Here x. That's all. Okay. Here hash include malloc h expected semicolon int x. Okay.
স্যার ওই স্ক্যানএফটার উপরে প্রিন্টএফটা সেমিকোলন।
All right.
element search.
Okay. So how many elements? So let's say 10. So 11, 2, 9, 13, oh, then 57, 25, 17, 1, 90. Let's say 40. Oh, it is not n plus 1, sorry. It will be n then. Starting index is 0, so it should be n. Are you getting my point? So this is little bit adjustment you are doing.
Yes, sir, yes,
Code and algorithm. You have to very extra careful about this. So 10 again, 11, 2, 9, 13, 57, 25, 17, 1, 90, and 3. Let's say 40. Yes, 40 is not found. Let's try again with successful searching. 10, 11, 2, 9, 13, 57, 25, 17, 1, 90, and 3. Let's say 25. Oh, star tr. Okay, sorry.
আচ্ছা স্যার ওখানে রিটার্নটা তো হবে না স্যার, কন্ডিশনের মধ্যে ইফ কন্ডিশনের মধ্যে কি রিটার্ন হবে?
স্যার ব্রেক স্টেটমেন্ট হবে না একটা?
No. The actual problem is tr is not moving, it is static at the 0th position. It has to move tr plus plus. Now it will. Because we have implemented the code part, that is fine. So no, there is nothing wrong in the logic algorithm. Only there is some gap, some extra lines you have to write in the code, due to which your code is not working properly. That thing, okay. 57, 25, 17, 1, 19, 25. 25 is found at 6th position. Are you getting my point? Okay.
Yes.
Yes. Okay, so we are done for today. There will be a very short quiz, and I'm sharing that link in the chat box. Just 4 questions are there. I will give you only 3 minutes, very easy questions. So within 3 minutes you submit the short quiz, and let's stop our today's lecture. Thank you for listening to the lecture. I'm stopping the presentation.
থ্যাংক ইউ স্যার।